In exercises 1 through 8, the function v of t is the velocity in meters per second of a particle moving along the x-axis. Use analytical methods to do each of the following. A. Determine when the particle is moving to the right, to left, and stopped. Let's graph number 2. The period is 2 pi over k, and in this case k is 3. Let's draw the y-axis and the x-axis. Ooh boy. And let's make 4 marks. And we'll make the fourth one the period, 2 pi over 3. Halfway would be 1 pi over 3, and half of that would be pi over 6. We have 1 6, 2 6, 3 6, which is pi over 2. Sine starts at 0, and the amplitude is 6. So this graph will go up to 6, back down to 0, down to negative 6, right here, and then back to 0. There's the graph. And on A, we want to determine when the particle is moving to the right, to left, and stopped. The particle is moving to the right when the velocity is positive, and this is the velocity graph. So 0 to pi over 3 is when the graph is positive. The graph is negative from pi over 3 to pi over 2. Notice I don't go to 2 pi over 3 because we're only looking at 0 to pi over 2. And then stopped at 0 and pi over 3. In letter B, we want to find the particle's displacement for the given time interval. And then, if s of 0 equals 3, what is the particle's final position? So we want to find the displacement. That is the integral from 0 to pi over 2 of v of t dt. And the integral of v of t is, let's see, it's negative 2 cosine of 3t. And we'll evaluate that from 0 to pi over 2. We need to plug pi over 2 in. We have negative 2 cosine of 3 pi over 2 minus negative 2 times the cosine of 0. The cosine of 3 pi over 2, let's look at that. 3 pi over 2 is right there, and the cosine is 0. This becomes 0. The cosine of 0 is 1, so the displacement is 2. The particle has moved 2 units. Now if we want to know its final position, it started at 3 and moved 2 units. So let's take 2, which is the displacement, and we'll add that on to where it started, and the final position is 5. In part C, we want to find the total distance traveled by the particle from 0 to pi over 2. We will take the absolute value of the integral from 0 to pi over 3 of v of t dt, and then we'll add that to the absolute value from pi over 3 to pi over 2 of v of t dt. Well, we already know that the integral is negative 2 cosine of 3t. We did that before, so we have negative 2 cosine of 3t evaluated from 0 to pi over 3, and then plus negative 2 cosine of 3t evaluated from 0, we have pi over 3 to pi over 2. And we want to take the absolute value of each of these. With total distance, we want the total area, the total displacement, if you will. That's negative 2 cosine of 3 pi over 3, or just pi, minus negative 2 cosine of 0. That's the first one. And then we will add that to, of course, we've got to take the absolute value of all that, plus the absolute value of negative 2 cosine of 3 pi over 2 minus negative 2 cosine of, this time, 3 times pi over 3 is just pi. The cosine of pi is -1. We have 2. Cosine of 0 is 1, so we have plus 2. Absolute value of that. Plus, we have cosine of 3 pi over 2. That's 0. And we have minus, minus, and then the cosine of pi is -1, so that goes to a -2. But we're taking the absolute value. We have 4 plus 2. So the total distance traveled is 6 units. Let's do number 4. We have v of t equals 6t squared minus 18t plus 12. And we will look at things from 0 to 2. If we plug 0 in, we get 12. 2, 4, 6, 8, 10, 12. Let's call 12 right here. When we plug 1 in, we get 6 minus 18 plus 12. That's a -12 plus 12. That is 0. And then when we plug 2 in, we get 0 again. The parabola looks something like that. Not exactly sure how far it goes down, but that really isn't going to impact how we do this problem. In letter A, we need to decide where the particle is moving left, right, and stopped. Left from 1 to 2. Right 0 to 1, and we will include 0 because at 0 we have a positive value for the velocity. That means it's actually moving right at 0. And then stopped at 1 and 2. In letter B, we're asked to find the displacement from 0 to 2. And we have 6t squared minus 18t plus 12 dt. That means we have t to the third times 2 minus 9t squared plus 12t. And we will evaluate that from 0 to 2. 2 to the third is 8. We have 16 minus 4 times 9 is 36. And 2 times 12 is 24. When we plug 0 in, all of that will be 0. -20 plus 24, that is 4. We have a displacement of 4, but if this thing starts at 3, at s of 0 is 3, then this is the displacement, and then we'll add 3 to get its final position. So the final position is 7. Started at 3, moves 4 units to the right, that means it stops at 7. And then on letter C, we're asked to find the total distance traveled by the particle. We need to split the integrals over the zeros. We have absolute value from 0 to 1 of v of t plus absolute value of integral from 1 to 2 of v of t dt. Well, we already know what the integral is. It's 2t to the third minus 9t squared plus 12t, and we'll evaluate that from 0 to 1 and make sure we count it as positive. We already know from the graph it is positive, but if we weren't using a graph, we would make sure we took the absolute value. So we have absolute value of 2t to the third minus 9t squared plus 12t, and we'll evaluate that from 1 to 2. 1 is 2 minus 9 plus 12. Absolute value, if we plug 0 in, all of that will be 0. And then plus the absolute value of 16 minus 36 plus 24, and then minus 2 minus 9 plus 12. And we'll make sure we take the absolute value of that. -7 plus 12, that is 19, plus, we have -20 plus 4 is 4, and then minus -7, we have -7, plus 12, that's 19, and that is -15, but we're adding 15, and that is 34. A particle travels with the velocity v of t equals t minus 2 sine of t for 0 to 4 seconds. What is the particle's displacement? We're going to find the particle's displacement from 0 to 4 of t minus 2 sine of t dt. We can do this integral with tabular method. We have t minus 2, 1, and 0 sine of t, negative cosine of t, and negative sine of t, and then we draw our diagonals. Make that a plus, make that a minus. The integral is t minus 2 times negative cosine of t, and then plus sine of t, and we're going to evaluate this from 0 to 4. Now, I do not know what the cosine of 4 is. That's going to be a decimal value. We're going to finish this one up with the calculator. Well, in order to solve this, if we have to use the calculator, we might as well not have done the integral, but that's okay if we did a little bit of the integral by hand. Let's go to math, and we want the integral. And if we're taking the integral, we don't want to plug this in and integrate again. We really want to plug that in if we're going to use FNINT. The function is t minus 2 times the sine of t. We're doing this on x, and we are going from 0 to 4. And we will enter, and the answer is negative 1.450. And then we're asked, what is the total distance traveled? And we're going from 0 to 4. Let's go to y equals and enter the function x minus 2 sine of t. And we'll make our window from 0 to 4, and if the y's need to be changed, we can do that. Let's graph it. Oh yeah, it's hard to see anything here. Let's go window, and let's make our y's, how about negative 1 to 1. We should be able to see the graph a lot clearer now. We need these two zeros, so we'll have to make 3 integrals. We'll calculate the 0, the first one, and we need left, right, and we'll guess right there, and it is at 2, 0. Our first integrals are from 0 to 2, and then 2 to the next 0 right here. Let's calculate that 0. We need left bound, enter, right bound, and then we'll guess right there. And the other 0 is 3 point, it's pi. So 2 to pi. And then we'll add that to pi to 4. And these are all of v of t. And we're going to make sure that we take the absolute value of all of these. Well, if we're going to unleash the power of our calculator, we might as well do this the easiest and the quickest way. If we look at the graph of this function again, it looks something like that. If we take the absolute value of the function, any place where the y values are negative, the y values will be turned positive. And even this part right here will become positive. And then if we calculate just all the area from 0 to 4, it'll all just be positive. And our calculator has the ability to do that. We can hit math, number 9, and then math, under num, we have absolute value. So we can take the absolute value of the function and then integrate over the absolute value. We'll go to variables, y variables, and enter y1 instead of entering the function in all over again. Whatever is in y1 now will go in that spot. And then we can say, do the integral over x, and we're going from 0 to 4 now. And the answer for the total distance traveled is, takes a while for the calculator to calculate this value, 1.914. The figure below shows the velocity for a particle moving along the x-axis. The displacement for this particle is negative. Justify your answer. We have a lot of positive area and a little and less, let's say, less negative area. This statement is false. The particle's displacement is not negative. The overall displacement is actually positive. True or false, if the velocity of a particle moving along the x-axis is always positive, if we have a function that is always positive, then the displacement is equal to the total distance traveled. Justify your answer. Well, that's true, because if we have this, let's say, finite area, this finite displacement, let's call it 7, then the area will be 7, and the absolute value of the area is also 7. So this is true.